In this video, we're going to review rational exponents. Up until this point, we've only done unit exponents or unit fraction exponents, and now we're going to work with a full rational exponent. I believe you've already done your homework for Algebra 1, so this should be a review. A rational exponent looks like this right here, where you have the base of a and an exponent of m over n. M and n can be any integer. This converts really nicely to two different forms. You can have your numerator of your exponent on the outside of the radical, or you can have the numerator of your exponent on the inside of the radical. I personally like to put it on the outside of the radical if I can find the nth root of a. If I can't find the nth root of a, so for instance, I can't find the fifth root of 8 without a calculator. So if I can't find the fifth root of 8, I would put the numerator of the exponent on the inside of the radical when I convert. So on your homework assignment for March 23rd, you're going to have to convert back and forth from rational exponents to radicals in order to simplify, or convert from radical form back to rational exponents. So the first section of your homework is going to be practicing converting your rational exponents to radical notation. So let's start with the very first example. Convert the following rational exponents to radical notation. The first example has a base of 3 and an exponent of 7/4. So how do we convert this to radical notation? Well, we're going to convert it into both forms. The first form being where we put in parentheses our radical. So we have our radical in parentheses. We put our base inside the radical, and then our denominator of our rational exponent is the number that we put in for the index. The numerator goes on the outside of the parentheses. And this is equivalent to writing the other form, which is the fourth root of 3. But we're going to now put the numerator on the inside. So I want both notations on your homework. The second problem says to take the 9th root. 9 is the denominator. Here's our base. We're going to take the 9th root of our base, which is xy, and we're going to raise that to a power of 4. So when we convert to the next form, we have the 9th root of, we have to put x and y in parentheses and put the 4 on the inside of the radical. All right, for our next example, notice that our negative sign is inside the parentheses, which means negative 16 goes under our radical. So for the first form, we're going to have the cube root of negative 16, and that's going to be raised to the 4th power. And then we're going to convert that to the cube root of negative 16 to the 4th power, all under our radical. And our last example, I'm going to have to squeeze this in, has our negative sign on the outside of parentheses, so it is not going to be inside the radical at all. So this is going to be negative for our first form, the 49th root of 17, all raised to the 23rd power on the outside of our parentheses, which equals the negative 49th root of 17 to the 23rd power, all under our radical. All right, so the next group of problems says that we need to convert from radical form to rational exponents. So now we're going to go backwards. We're given a radical, and we need to convert that radical back to rational exponents. Well, in the previous examples, we found that the index is the denominator of our rational exponent, and the power is the numerator of our rational exponent. So if you look here, if I am in this form right here, my index is the denominator, my power is the numerator. So I'm going to write my base, and then I'm going to take my power and put it in the numerator, and then my index and put it in the denominator. All right, how about the next example? Well, I have my base. I'm going to write my base again. And this one has the power under the radical, like up here on your screen, the top right of your screen. So I find my power inside the radical this time. So that is my numerator. And my index is 5, so that's my denominator. And then I'm going to do the next example, and I notice this time that I have a negative on the outside. So I'm going to need to have parentheses here because I'm not going to put my negative inside parentheses. All right, so I'm missing my index on this one. So I'm going to write in my index. This is a square root that has an index of 2. So for this, I'm going to write my base of x. All right, my power again is on the inside of my radical, so that's my numerator. And my index is 2. All right, so again, I'm going to, my negative is on the outside of parentheses, so I'm going to put my negative here, and I'm going to write my base, which now I have more than one item in my base, so I have to provide parentheses y, z, and put my entire base in parentheses. The power is on the outside of the radical, so that is my numerator, and the index is 11. All right, so that's how you convert from radical form to rational exponents. Be very careful about your negative. If your negative is outside of your radical, then your negative needs to be outside of your parentheses when you convert. So the next set of examples says to evaluate each expression. It's really helpful to convert to radical form. And I like to use this version of the equivalent of a rational exponent because in most cases I can find the nth root of a. So let's go ahead and do the first example. My root is going to be 2. My base is going to be 4. That goes under the radical. And then 5 is my power. When I have an index of 2, that means I'm taking the square root. The square root of 4 is 2. And I'm going to raise that to the 5th power. 2 times 2 times 2 times 2 times 2. What does that equal? That equals 32. All right. So now in this example, notice my negative sign is inside my parentheses, so that negative must go inside my radical. So I have a negative 27 as my base. My index is 3. And then my power is going to go on the outside. The cube root of 27 is 3. So the cube root of negative 27 is going to be negative 3. What is negative 3 raised to the 4th power? Well, I know negative 3 times negative 3 is a positive 9. So this is a positive 9, and that is a positive 9. So that's 9 times 9. So negative 3 to the 4th power is just 81. All right, so now my base is going to be the fraction, 25 over 36. So let's go ahead and write my base inside my radical. My index is going to be 2, so I'm taking the square root, and then I'm cubing that answer. Well, I know the square root of 25. When you find a root of a fraction, you find the root of the numerator and find the root of the denominator. So I know the square root of 25, and the square root of 25 is 5, and then the square root of 36 is 6. But now I'm cubing that. So it's 5/6 times 5/6 times 5/6. And if I multiply all that out, I get 125 over 216. All right, so now the very last thing we're going to do is we're going to evaluate an expression that has a negative rational exponent. And we have to remember what a negative exponent does. It takes the reciprocal of your base. So when I write the reciprocal of 81, it's 1 over 81. And then we raise our base, which is 81, to the positive of my exponent. So this tells me that I am taking or finding my base is 81, so it's going to go under the radical. My index is 4. And then when I find the fourth root of 81, I'm going to cube it. So the fourth root of 81 I know is 3, and then I'm going to cube that. 3 cubed I know is 27. All right, last set of examples here. We are going to use our rational exponents to simplify each of these radicals. So the very first thing we should do, it does say use rational exponents. So I'm going to convert to rational exponents. So I notice I have 2 things in for my base. And what I'm going to do with both of those, they're both being raised to the same exponent. So I'm going to write them as such. The 12th root of x times y in parentheses raised to the 3rd power, because this is equivalent to this. So now I'm going to go ahead and change this to rational exponents. So x and y are my base. My numerator is my power. My denominator is my index. And you notice that 3/12 simplifies. When I simplify that fraction, I get 1/4. So when I go ahead and convert back to radical form, my base is xy. That goes inside my parentheses. My index is 4, and my power is 1. When your power is 1, you don't need to write it. So this is my final answer. All right, so let's go ahead and do the same thing in this example. I only have one thing for my base, so I'm just going to write my base. I'm going to raise it to, the power is in my numerator, the index is my denominator. And when I reduce 5/20, I get 1/4 as the exponent. Again, this is my base, so I'm going to write that under my radical. The 4 is going to be my index. And again, my power is 1. I don't need to write it. And I'm finished with this problem. Hopefully this will help you on answering the questions on your homework assignment correctly.